Hi, this session is the challenge section on your practice test on algebra and the index laws. So here are the questions in the challenge section, just in case you don't have your sheet with you, and we'll go through them all. So with this one here, we can see the index law that we'll be using is the one that involves brackets, and we know that if there's a power on the outside, it gets multiplied with every power on the inside. So with the first fraction here, we've got 2 times 3, there's a separate bracket here. Down below has its own bracket, and the power outside is 3. Don't forget the k has an invisible 1, so 3 times 1 and 3 times 3 there. With this one here, this fraction, you notice the bracket covers both top and bottom. So this 3 is multiplied with everything, top and bottom. So the 3 has a power 1, the j has a power 1, the 4 has a power 1, and also the k. So every single one of those is multiplied by that 3. So top and bottom. So we should end up with 3 times 2 is 6, so k to the power of 6 over j to the power of 9 and k to the power of 3 times, and everything here will just be to the power of 3. So 3 to the power of 3, j to the power of 3 over 4 to the power of 3 and k to the power of 3. Now the next thing I'm going to do is evaluate my numbers. That is 3 to the power of 3 and 4 to the power of 3. So evaluate means to show the value. So 3 cubed is simply 27, and 4 cubed is 64. And then we can start simplifying our variables. Now with 27 and 64, I can't think of a factor that goes into both of those numbers evenly. And of course you can use that fraction button on your calculator, put it in as a fraction, and see if it can be simplified. But I can't think of a number, so I think that's right. So I'm going to start simplifying my variables as well. So I'll get my fraction lines ready. You can do it how you like, because I know working out can get a bit messy. So I've got 6 k's on top. Do I have any k's on the bottom? Well, I've got 3 down here and also 3 down there. But in total, how many do I have on the bottom? I have 6. So basically, the k's will disappear, because if I take away 3 from here, and then I take away 3 from the top, I'm left with 3 up here. And then I still have 3 up here and 3 down there. And that 3 can go and that 3 can go. So you can see how the k's actually gone. And we're done with the k's. Next, I've got 3 j's up here and 9 j's down there. So take away our smallest amount, which is from the top, and 9 take away 3 is 6. So what I'm left with up here is just a 1 times 27, and down here I've got j to the power of that 6 times, over here it's just 64 times 1, so just 64. So now I multiply them together. Now if you decided to multiply first and then simplify, you can still get the same answer, but remember, it's a skill to simplify before you multiply, especially when you're dealing with numbers and it gets quite large and it makes it harder to simplify. So now I'll multiply everything out. 1 times 27 is 27 over, I've got j to the power of 6 times 64. So the 64, I'll just write it first. And that's our answer. 27 over 64, j to the power of 6. With our next question, once again, we see brackets and then index law. So the power 4 is multiplied with everything, every power inside the brackets, including the invisible 1. So 1 there and 1 there. And of course, that times that, and that times that. And don't forget the 16 also has a power 1. That's multiplied with the 2. So we'll just multiply these out. So we end up with 2 to the power of 2, or 2 squared, it's 4 times 1. That was a 2. So 2 to the power of 4. And then w to the power of 4 times 3's on the outside. So in between the 3 and the bracket, there's a times. So I'll put a times there. And then we've got 4 squared and x. And down here we've got 16 squared, w to the power of 4, and x, 3 times 2 is 6. Now the next thing I'm going to do is evaluate all of my numbers. So 2 to the power of 4 is 16. Now I've got 3 times. Be careful. Don't go 3 times 4 is 12. That is not 4. 4 squared, 4 times 4 is 16. So we really have 3 times 16. Okay. And down here, we've got 16 squared, which is 256. Now you may have noticed you could have actually simplified. See how we had a 16 up here and a 16 there? And then 2 16s on the bottom, or 16 times 16. We could have just crossed off all the 16s because we end up with the same thing on the top and bottom. But if that confuses you, then we'll keep going this way and you'll see what I mean in a second. So now up here, I'll keep simplifying. I've got 4 W's here and 4 on the bottom, so my W's can go. Whoop, I'll just change my color. So W's are now gone. There's a 3 sitting there, but for now I'll leave my numbers. I've got x to the power of 1 and then 6 x's on the bottom, so that one can go. And I'm left with 5 x's on the bottom. So now I'm going to just multiply everything out with my numbers. So I've got 16 times 3 times 16. There are no variables on top, so that gave me 768. So on the bottom, I'm left with 256, and I'm left with x to the power of 5. So I'm almost there. Now, please make sure you simplify your fraction. Now, like I said, you can put it in your calculator, put the fraction button in, and keep in mind, we could have actually simplified before we multiplied, but we just did it this way before I change. And 768 divided by 256 leaves me with 3. So your answer is going to be 3 over x to the power of 5. Okay? So basically what we had, this would have cancelled out 1, and it goes into 768 3 times. So just make sure that 3 is sitting on top, because x to the power of 5 is stuck on the bottom. And I just realized I made a mistake. Here should be x to the power of 2. So that should really be, take away 2 from the top and 2 from the bottom. I should have an x to the power of 4. So that's why it's important during a test you go back and check your working out. So it should be 3 over x to the power of 4. Now our next 2 questions involve factorizing. And the reason why they're more challenging is simply because we've got a negative to take out as a factor. And it's not really hard at all. So first of all, we know with factorizing, we get our brackets ready. Now, this is the part where it's a bit different to what we've been doing. Don't get this negative and put it in the middle, because you notice how there's a negative out here? Whenever you have a negative out on the front, that is something you have to take out. So if I take out a negative out here, the trick is everything that's left inside in terms of the operations, so in this case I have subtraction, becomes the opposite. So instead of a negative, I'll put a positive. So the trick is, if you take out a negative, what's left on the inside becomes the opposite. And that's because if I multiply this out, a negative times a positive gives me a negative. If I had a negative in here, because I just put it down, because I thought, oh, a negative here and negative there, when I multiply this out, I'll get a negative times a negative will give me a positive. I don't have a positive here, I have a negative. So we've got to change that to a positive. And this negative is already taken out, so it's automatically a positive here as well. So then all you're going to do is simply factorize as you normally would. I've got 72 and 16. So highest factor I can think of at this stage is 8. So 72 divided by 8 is 9. 16 divided by 8 is 2. Now, was 8 my highest factor? It looks like it was, because 9 and 2 they don't have any more factors. So I'll put my 8 down, and my leftovers, we've got 9 and 2. Next, we've got 1b on this side and 1b on that side, so I can take out a b from both sides. That's my highest factor. Done. A c on both sides, I can take a c out. Done. And unfortunately, d is by itself, so d is just stuck there. And that's it. And you can see how if I multiply this, I'm going to have a negative 8 times a positive 9. will give me a negative 72. And a negative 8 times a positive 2 will give me a negative 16. Exactly what I started off with. So the trick with these ones is, if you take out a negative, put the opposite operation. So in this case, I had a negative, so I put it as a positive. So once again, our next question, you notice we have a negative on the outside that we have to take out. I'm just writing the questions now, the numbers from the actual test. So this is 10B. So my first step is take out this negative here. But when I do that, so I'll take it out. And now everything else in here becomes the opposite. So instead of a positive, I now have a negative in there. And that's it. And all I've got to do now is factorize 30 and 45. Well, if I divide them both by 5, let's see if that's my highest factor. 30 divided by 5 is 6. 45 divided by 5 is 9. So it wasn't my highest factor. I think 15 was, but that's okay. So what I've done is I've taken out a 5, but I can still keep simplifying. And this is something I haven't showed you yet, so it's actually really easy. I'm going to multiply it with whatever I continue to take out. 6 and 9 both have a factor of what? Of 3. So 6 divided, so I'm going to take it out, take it a 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So my leftovers finally were 2 and 3. It cannot be simplified further. And what is 5 times 3? 5 times 3 is simply 15. So the highest factor, it was 15. I didn't get it straight away, so I multiplied the factors that I ended up with. So that's another way of doing it. If that tricked you, then don't worry. Just next time think of the highest factor. But that's just another way of doing it. So then I keep going. I've got a J on this side. No J's there. J is stuck there. K is also stuck there. But L, I've got 2 L's here and 3 L's there. So I take out my smallest amount. It's gone. And 3 take away 2 is just 1 L. And that's it. So expand this to see if we get the right answer. Okay, negative 15 times 2, yes, is negative 30. Got a L squared and J and K sit there. I know it's not the same order, but we know order doesn't matter, so that's correct. Plus, negative 15 times negative 3 is positive 45. L squared times L is L cubed. And yeah, perfect. Our next question is sort of a challenge question, but it's actually not too challenging. The only tricky thing is that's a negative Z, so we're working with negatives. So we've got 2Z times 3. I'm going to do this one mentally. You can use working out by putting it in brackets, but I'll just do this one mentally. 2Z times 3 is just 6Z minus, it'll be a negative. 2Z times 2Z is 4Z squared. Now here I've got to be careful. A negative Z times a positive Z will give me a negative Z squared. That's a Z. And negative Z times it's really a negative 4, will give me a positive 4Z. So just be careful with your negatives and positives. Now I won't stop there because I can actually keep simplifying. I might circle to my left to make sure I don't make a mistake. So starting from here, I've got 6Z. Any more Zs? Yes, plus 4Z. 6 plus 4 is simply 10Z. Done. And I've got a negative 4Z squared minus Z squared, or 1. So what's minus 4 minus 1? It's minus 5Z squared. And that's it. There's nothing else I can simplify. That's our answer. Now our next question involves adding and subtracting fractions. And this one is more challenging simply because we've got the fraction looking quite complicated. But it's actually not hard at all. Now, whenever you notice, or whenever you have, for example, in this case, x take away 4, or something separated by subtraction or addition, and it's in a fraction, whether the top or bottom, I want you to put brackets around it, because they're actually together. They can't be separated. So they're sort of stuck together. Sometimes they put brackets for you, sometimes they don't. So you just do it yourself. Now, to get the same denominator, all we're going to do is multiply these two numbers with each other. Because remember, x minus 4, if x was, for example, 5, I'd have 5 take away 4, which is just 1. So x minus 4 is a number, x plus 7 is a number. We just don't know what x is. But if we know that they're different numbers, all we're going to do is multiply them with each other. So what we'll end up with is, down here we'll have x minus 4 times bracket x plus 7. And the same thing I must do on top, x plus 7. Now I've got the divisible times there. And on this side, I'll do the same thing. Times by x minus 4 on the bottom. And on top, times by x minus 4. The times can be invisible. So now, don't expand anything. First, write it out all on one fraction. As one fraction. So on the bottom, x minus 4 times x minus 7. How you write this is simply, leave it in brackets, x minus 4, and don't put a times, just, there's actually an invisible times in between these two brackets. And you just write it like that. So that's saying x minus 4 times x minus 7. I know it might look complicated for the first time, but that's how we do it. But up here, we got what? 2 bracket x plus 7. Now, there's a plus in the middle. And it's really important that you, if it was a negative, if it was a takeaway, if I put a plus there and I write my 3 bracket x minus 4, that is saying I have now what? A positive 3. So if it was a negative, you'd have a negative 3. That's why it's important you don't expand it now. Expand it once you have it all on the one fraction line. Because a lot of students get stuck on that part, especially when there's a negative. And now the bottom will stay the same. We do not expand the bottom, if you know how to do expanding on that. But the top we can expand. So we've got 2 times x, 2 times 7, positive 3 times x, and positive 3 times 4. So we end up with, so that's still the same on the bottom. So x minus 4 and x plus 7. So we've got 2x plus 14. It's positive 3x minus 12. Now simplify what we can on the top and we're pretty much done. So I'll just make more room up here. It's not so squishy on the bottom. So I've got a 2x plus 3x, which gives me 5x, and a positive 14 minus 12. So that will leave me with positive 2. And on the bottom, I've got x minus 4 and x plus 7. And that's it. There's nothing else we can simplify. We don't expand the bottom, and we're done. All right, with our last one, this is a tricky one as well. Whenever you see a negative in between two fractions, like this, I want you to, when I do an arrow, to remind yourself that we have a negative there. Because if you forget there's a negative there, you'll make a big mistake. And you'll see what I mean in a minute. So now our denominators in this case are 5 and 3. So it's pretty straightforward. Once again, we need the same denominators, so let's multiply them with each other. Times by 3. And I forgot, remember that trick I told you? If there's no brackets around algebra and a number, in this case 2x plus 1, please put it there. And I put a bracket around x plus 2. So times by 3. I'm not going to write times by 3 like I did in the bottom. I'm just going to put it outside the bracket because that's saying 3 times 2x and 3 times that 1. And the same thing on this side. So times 3 by 5. But instead of writing times 5 up there, I'll put it outside the bracket. Now, do not start expanding just yet. Remember, we have to write it all on one fraction line, especially now because we have a negative. So we end up with 15. So our common denominator was obviously 15. And then we've got 3 bracket 2x plus 1. There's a minus, now 5 bracket x plus 2. And you can see why it was important we didn't expand straight away, because that 5 you can clearly see now is a negative 5. We'll have negative 5 times x and negative 5 times positive 2. And also expand that side. So finally we end up with the denominator is 15. So we've got 3 times 2x. So 3 times 2 is 6x plus 3. Now, negative 5 times 5x, that's negative 5x minus 10. Okay? Now, simplify what we can on the top. 6x minus 5x is just x. Now, 3 minus 10 will leave me with a negative 7. Now, let's just check with this fraction here. Is there anything else I can simplify? No, there isn't. And we know that with fractions like this, because 8 takeaway separates the x and 7, I must simplify everything from 1, 2, 3 parts. If I can't, then we can't do it. So that's our final answer. Thank you.